What's up guys, welcome back to the channel. In this video tutorial we are going to discuss about and learn about what are the various types of traversals in a binary tree. So if you have don't watched our previous video, I requisite you to please watch that video and then come to this video. Means in that particular video, in a previous video of this tree series, we have discussed about how to create a tree using a recursion. So let us create a tree. Let us suppose we have created a tree like this one. So this is a node 1, let us suppose, and here is its left children, let's say 2, and here is its right children, let's say 3. So you also not need to take care that I am taking a simple binary tree, I am not taking a binary search tree. We will be discussing the concepts of a binary search tree in our next videos. In these video tutorials I am only discussing all about the binary tree. So in the current videos, so let's take the left children of 2 as a 4, and let's take the right children of a 2 as a 5. Sorry. And let's take a right children of 3 as a 6. So here I have taken a binary tree. So we have already discussed in a previous video how we recursively create this tree. So basically the yellowish node, this node is basically representing a current node. So what this is node is, sorry, root node. This node is our root node. So I can say this is my root node. So if you are confused about how to implement a tree data structure, I again repeat that in my previous video I have already discussed about how recursively using a recursion algorithm we implement a tree data structure. And when I am teaching in that video, I have explained one concept that any type of operation we are performing in a tree data structure, we will start from a root node. So this is our root node from where I need to start. So whenever I need to perform any type of operation like insertion, deletion, updation, I need to start from any point. So that point is basically a root node. So root node is the first node of our binary tree, and now we will do a traversal. So we will discuss what will be how we will do traversals of the binary tree. So let us see first of all what is a traversal is. So what is a traversal? Let me write here traversal. Traversal. So let us first of all note what a traversal actually is. So basically, let us suppose this is a binary tree. So if I have taken this binary tree, let me erase this one. So if I have taken this binary tree, traversals means visiting each and every node or each and every data element stored in a tree. Or for example, if you learned about the array data structure, it look like something like this. Suppose this is an array 1, 2, 3, 4, and so on. I am taking a 5 elements like a 5. So this is, if this is an array, the traversal of this array means I need to visit each and every element. First of all I will visit a 1, then I will visit a 2, then I will visit a 3, then I will visit a 4. Clear? To visit each and every element of a data structure, or to access each and every element at least once stored in any data structure, that process is known as a traversal. So what we are going to do is we will be seeing that how to do the traversal. Clear? So basically I am showing you a traversal of a tree. So in the tree data structure, how we will do a traversal, let us discuss. So let me create a tree here. So let us create a tree, quickly create a tree here. So let us suppose this is a node 1 here. Clear? So its left children, let's say 2, its right children is let's say 3, the left children of 2, let's say 4, and the right children of 4 is a 5, and the right children of a 3 is a 6. I am not taking the left children of a 3, just for the demonstration I am creating a tree here. So what is the traversal of this tree? So basically whenever we are traversing on a tree, we are having 3 types of a traversal. So first of all, if I ask you what is the traversal of a tree, what should be your answer is, the traversal of a tree means to visit each and every node of a tree at least once. For example, the traversal of this tree will be, first of all, I can visit a 1, I need to visit a 1, I need to visit a 2, I need to visit a 3, I need to visit a 4, I need to visit a 5, and I need to visit a 5, and I need to visit a 6. So basically, to visit each and every node of a tree data structure, that process is known as the traversal. So whenever I am doing a traversal of this tree, I need to visit every node of this tree data structure. So let me explain. So in the tree data structures, we are having the three types of traversals. What are the three types of traversal? Pre-order traversal, post-order traversal, and in-order traversal. So first of all, let us discuss what is a pre-order traversal is. So let us discuss pre-order traversal. Pre-order. So first of all, I am discussing a pre-order traversal. Clear? So pre means what? Which comes first. So pre means first. So basically, in pre-order traversal, we are having a pattern like this one. We are having a pattern like this one. You need to absorb this pattern. First we are having a root, then we have a left, and then we have a right. What does it mean? Let me explain. So basically, in a pre-order traversal, what we are going to do is, as I have already told you, in any kind of traversal of a tree data structure, we will always start from what? This root node. So basically we start from this root node, and in this case, in a pre-order traversal, first of all the root comes, then we move to the left part, then we move to the right part. This is very important. Clear? First of all we go to the root, then we go to the left, and then we go to the right. As its name suggested, pre means first move to the root. Root comes first, and then we move to the left part, and then we move to the right part. So how this traversal works? First of all, we are at the root. So basically, according to pre-order traversal, first of all we will access the root node. So what is the root node is currently 1. So we will write it in the answer 1. Clear? And then go to its left part. So from 1 we will go to its left part. So basically, now we are currently at the node 2. So what is the current root? That is also a 2, because according to pre-order traversal, first of all we need to take a root, current root in the answer, and then we need to move to the left subtree, and then we need to move to the right subtree. So first of all we are at the 1, and we have taken this, and then we need to move to the left subtree. So we have moved to the 2, and now what is the current root if I say to you? So the current root is 2. So I will simply write here 2. Again, according to pre-order traversal, root is accessed, then we need to move to the left subtree. So what is in the left subtree of a 2? In the left subtree of a 2, I have a 4. So again I have a 4. So what I will do is, I will simply access the current root. What is the current root? 4. So I will simply write it into the answer. So let's write it into the answer. And then after that, I will move to the left subtree of the current node, because first we go to the root, that is a 4, then go to its left subtree. And if I talk about the left subtree of a 4, there is a no left node in its left subtree. So here will be a null. I can say it will be a null. So I will simply return from here to here. Then I will go to its right subtree. So there is nothing in the right subtree. So again what I will do is, I will simply come back and go here. So for the 4, the pre-order traversal is completed, and now the control goes back. And if you carefully see, for 2 we have taken it as a root and the answer, and then we move to its left subtree according to pre-order traversal rule. And now what we need to do is, 2's root and left part is completed. Now we move to its right part. So what is in the 2 to right subtree? It is a 5. So currently we are at a 5. So what is the value of a root? I will say it is a 5. So simply add 5 to the answer. After adding 5 to the answer, we will move to the 5 to left, because there is nothing in the 5 to left. So I will simply comes back, and then I move to the right part. So because there is nothing in the right of 5, I will again come back. So if you carefully see, for this two, the traversal, the pre-order traversal is completed because we have moved to its left subtree as well as its right subtree, and now the control goes back to this one. And if you carefully see, one is already taken in the answer because it is the current root, and its left subtree is also taken as an answer. What we need to do is we need to move to its right subtree part. So from 1 we move to its right subtree part, which is a 3. And now what is the current root value? That is a 3. So basically I will write here 3, and then according to pre-order traversal rule, first of all we goes to the left subtree of the current root. So in the left subtree there is nothing, so here will be a null, so we will simply return to back to the 3. And then when current root is taken, its left subtree is taken, we will move to its right subtree. So what is in the right subtree of 3? That is a 6. And what is the current root value now? The current root value is 6 now. Clear? So I can write here 6. And then I will move to the left part of a root where is nothing present. So I will simply return to this part. And again I will move to the right part of the 6. There is nothing. I will simply return to this part. So basically, if I talk about the pre-order traversal of this binary tree, that will be at 1, 2, 4, 5, 3 and 6. So this is a pre-order traversal. Let me quickly explain again. What we need to do is, so let's again take this concept and understand how it works like. Clear? So how does it works is basically very simple. Clear? So basically I told you that in a pre-order traversal, what we do is in a pre-order traversal, first of all we go to the root. First of all we access the root, then we access its left subtree part, and then we access its right subtree part. Okay, so this is how we calculate the pre-order traversal. So let me explain quickly. So first of all we go to this node 4. This is the current root, so we have taken it into the answer, and for this, after this taking it as in answer, we will move to its left part. In the left part, 2 is current root, so we will take it in the answer. We will move to its left part again. So in the left part, 4 is the current root, we will take it into the answer, and we will move to its left part, because in the left part we having a nothing, we having a null, so we will simply come back to this current node. So after that, if you carefully see, we will move to its right part. Clear? Root, left and right, this is very important rule. There is nothing, so we will simply come back to this 4. After this we will go back to 2. For the 2, the left subtree part is completed, and now we will move to its right subtree part, because see, root, its left and its right. So we will move to the 5. So for the 5 we will first of all take it into the answer, because first of all we take a current root in the answer, and then we go to its left subtree, and then we go to its right subtree recursively, and then we go to 5 to left, there is nothing, 5 to right is nothing, so we come back to this. So for the 2, the pre-order traversal is completed, so we will come back to this part. So for the 1, we have taken 1 in the answer as a root. Its left subtree, if you carefully see, this is whole the left subtree of a 1, it is taken in the answer. Now what we will do is, we will do the traversal of its right subtree. So what are the nodes in the right subtree? First we are having a 3. So as a current root, I will add it to the answer. And is there anything in its left subtree? No, there is nothing in the left subtree of a 3. It is a null. So basically we move to its right subtree. When we go to its right subtree, in the current stack frame, what is the value of the current root node? That is a 6. We simply take 6 into the answer, and we go to its left subtree part recursively. There is nothing in the left subtree part, and we will go to its right subtree part. There is nothing in its right subtree part also. So at the end, the recursion is completed for all the nodes. We have scanned, or we can say left and right subtree part. So this will be the traversal or pre-order traversal of this binary tree. Let us quickly discuss about the in-order traversal, and then we will discuss the post-order traversal. So let us quickly see what is in-order traversal actually is. So let me erase all of these things and I will explain the concept of in-order traversal. So if you carefully see, in case of a pre-order traversal, first of all we are accessing the root node and then we are going to its left subtree part recursively, and after that when its left part is fully traversed, then we go to the right subtree part of the current node. But in case of a in-order traversal, first of all let me explain the post-order traversal. So what is a post-order traversal is? Post-order traversal. So let me explain what is the post-order traversal actually is. If you understand the pre-order traversal, post-order traversal is very easy for you. So let us discuss. So basically, in case of a pre-order traversal, we first access the root node and then we move to its left subtree and then we go to its right subtree and collect all the nodes, and we do this step for each and every node. Clear? We do this step for each and every node. But in case of a post-order traversal, as its name suggested, post means after. So first we go to the left subtree part, then we go to the right subtree part, and then we go to the root node. Clear? Then we come back to the root node. So the only difference is basically I can say that it is the reverse of a pre-order traversal. Means in case of a pre-order traversal, first of all we go to the root node, we add it to the answer, and then we send the recursion to its left subtree part, and then we finally send the recursion to its right subtree part. But in case of a post-order traversal, what we will do is we will first of all traverse the left subtree part, and then we will traverse the right subtree part, and after that we come to the current node and add it to the answer. So let us see how it works. So first of all, any type of a traversal we will do, we will start from the root node. So we start from this particular node. So it is a root node. First of all, we need to go to its left subtree part. So let us go to its left subtree part. I will go to this. Again, it is a root node. So I will go to its left subtree part first for each and every node. So I will go to this. Again, this is a root node. So I will go to its left subtree part where I get nothing. Here is a null. So this is a base condition. When I got a null, I will simply return. After the completion of the traversal of a left subtree part of a 4, I will go to its right subtree part. So there is nothing in the right subtree part. Clear? First it goes to the left and then we goes to the right. And when the right traversal is completed, because there is nothing present in the right subtree part, we will come back to this 4. And now we are at the current node. So finally we will add the current root to the answer. So we will write here 4. And because for the 4, the post-order traversal is completed, so we will simply return to this 2. If you carefully see, for the 2, we have traversed its left subtree part. Now we will move to the right subtree part of a 2 first. So we will go here, and for the 5, which is the current root, we will go to its left subtree part and got nothing. Here is a null also, and here we will also got a nothing. Here is a null. After the completion of a left and right traversal of the 5, we will simply add the current root, that is the 5, into the answer. So let me write it in the answer, and then finally we will come here. So because for the 2, if you carefully observe, for the 2 the traversal is completed. Clear? For the left subtree traversal is completed, right subtree traversal is completed. Now current root, that is the 2, is added to the answer. So simply add it to the answer. Clear? And now the left subtree part of this 1 has been completed, and now I will move to the right subtree part of the 1. So I will go to this part. Again 3, I will move to the left part of a 3 first. So let's move to the left part. I got nothing, and now I go to the right part of a 3, because first of all we need to go to the left subtree of each and every node, and then we go to the right subtree of each and every node, and finally when we come to the current root, we will simply add it to the answer. So we move to the 3 to right subtree part. Here we are having a 6. Again for the current 6, we go to its left subtree part and we got nothing, and then we move to the right subtree part, we got nothing, and finally we come to the 6 and add this current node 6 to our answer simply here. And then the recursion goes back here, because for the 6 the post order traversal is completed. So from 6 we go to this 3, and as we see, for 3 the left and right path has been traversed. So 3 is the current node, so simply add it to the answer. So for the 3 the traversal is already completed, so the finally control comes back to this 1, and for this 1 the left subtree has been traversed as well as the right subtree has been traversed. So the current node is what? Root is 1, so simply add root to the answer. So it will be the post order traversal of this tree. So I hope you understand how to calculate the post order traversal, how to find the post order traversal of any given tree. The only difference in the pre-order and post order traversal is what? In case of a pre-order traversal, first of all we are going from current node to the left, we are accessing the current root node, and then we are traversing its left subtree part, and finally after that we are traversing its right subtree part. So in case of a pre-order traversal, the pattern will be like a root, left and right, but in case of a post order traversal the pattern will be like a left, right and root. Let us quickly discuss about the pattern in case of a in order traversal, which is very important. Clear? So let us discuss about the in order traversal. It is important because most of the questions in the binary search tree are based on this criteria. So let me again draw the tree quickly for better understanding. Clear? So quickly let me again draw the one tree. So let's say this is the 1, this is the 2 here, this is the 3, 4 and there is a 5, and finally I am taking a note 6 here. Clear? So what is the in order traversal is a very important. So in order traversal, so in case of an in order traversal, as its name suggested, first of all we move to the left part of the current node, we traverse the left subtree of each and every node, then we go to the root, and then we go to the right subtree. So this is very important. So let me remind that in case of a pre-order traversal, first of all we access the current root node, then we go to its left subtree part and do the same steps, and then we go to the current root node to right subtree part and repeat the same step. But in case of a post-order traversal, first of all we move to the left subtree part of the current node, then we move to the right subtree part of a current node, and then finally we come to the root node. Clear? But in case of an in order traversal, first of all we will move to the left subtree part, and then we move to the root, access the root, and then we move to the right subtree part. This is clear. So there is no change, only difference is what? First of all we go to the left subtree part and then comes to root, and then we go to the right subtree part. So basically let's start our traversals doing from the first node as usually. So when we start from this, the first thing is we go to its left subtree. So simply we go to its left subtree. Again, this is the current node. The first thing is we will go to its left subtree. Again for this 2, I will go to the left subtree. Again for this 2, I will in this 4, I will go to its left subtree. So there is nothing present in its left subtree. Clear? So I will simply come back to this 4. Clear? So when I come back to this 4, this is the current root, I will simply add it to the answer. So let us add it to the answer. After adding root to the answer, let's go to its right subtree part. So there is nothing present in its right subtree also. Clear? So for this 4, the traversal or in order traversal has been completed, and now I go to this 2. So if you carefully see, for 2 the left subtree has been traversed. So the current root is 2. So we'll simply add 2 to the answer and add to the right subtree. We move to 5, and simply again for the 5 we will first of all go to its left part. There is nothing in its left part, and then we come to the 5 and add it to the answer, and then we go to its right part. There is nothing to its right part, so we simply come back, and finally we go to the this 2. So if you carefully see, in this way we are traversing it, clear? And then if you carefully see, for 1 we have traversed its left subtree whole, clear? So we will have traversed the left part. Now we will simply add this root 1 to the answer. Let me add it in the answer, and then we go to this right subtree part. So I will move to this part, and after going here, first of all I go to the current root to left part where I got nothing, and then I come back to 3 and add it to the answer, and then I go to its right part here. Again for the 6 I go to its left subtree, I got nothing, then I come to the current root, that is 6, from back here, so add it to the answer, and then I go to its right part where I got nothing. So finally I come back here. So basically, and then the recursion goes here, here, and control comes out of the program. So basically this is the in-order traversal, in which first of all we traverse the left subtree nodes of the current node, then we go to the current node and add it to the answer, and then similarly we traverse the right subtree of the current node. For each and every node we are doing this step. So one thing we need to remember for each type of a traversal is, what will be the base condition whenever we are writing a program. We will discuss about the code of this thing in the next session. So whenever we encounter a null node, this is a null node. So whenever we encounter a null pointer or any node to left or right field is equals to null, means there is no left children, right children, we will simply return from that state. We will simply return. That will be a base condition. So in the next videos we will be seeing how to basically implement a pre-order, in-order, and a post-order traversal. Until then, make sure you are subscribed to our channel, press the bell icon. So see you next video. Till then, bye bye.